So as an example, Marcus, when he turns 25, he decided to start investing every year in an IRA. An IRA is an individual retirement account, and so it's money that people put away for retirement. And once you have a regular job, it's a very good idea to put money regularly into an IRA. And so you should do that every year, or if it's easier for you, do it every month. Sometimes your employer has a pension plan or a retirement account that you can contribute to, and usually those are good to use. If you don't have one, you should open an IRA at your bank or an online account and start saving for your retirement. That way you'll have money and you'll see how good the return can be. So we're going to look at Marcus. He's going to invest $2,000 into an IRA with an APR of 7.5%, and it's going to be compounded annually. So I'm seeing a lot of information that I need to use. 7.5%, that's going to be my R. Compounded, we're going to see that pretty much every time because of our formula here. And then the compounded annually, that's going to give me an N equals 1. Marcus is going to invest $2,000, so that's going to be my PMT, my payment. 2,000 each year. So he's making every year he's making an investment of $2,000. And the APR we got, the compounded annually, how much money will be there when he retires at the age of 65? 65 minus 25, which is how old he was when he started, is going to give you 40. And so he will make 40 years of deposits, and that will be my T equals 40. So setting up this formula, write it out first. FV equals PMT, and then we have 1 plus R over N raised to the NT power minus 1 all over R over N. So looking at Marcus's situation, I don't know the FV, the future value. I do know his payment amount is $2,000. And we'll do 1 plus his rate is 0.075. That comes from the 7.5%. And the N is 1. The N is 1 again. And then the T is 40. Subtract 1 from that once you've calculated all that part. And then it's over R over N. R again 0.075. N again is 1. Okay, I see a lot of 1s in my denominators. That's really nice because that's going to reduce right away. So let me take care of those. And while I'm at it, I see that I can calculate all of this here. 1 plus 0.075 will just be 1.075 to the 40th minus 1 all over 0.075. So I just did a couple of simple things to help speed up my calculations a little. I do want to take a look now at doing this on the calculator. And so I'm going to start inside the big square brackets, which remember are just like parentheses, and I'm going to do the 1.075 to the 40th power first, subtract the 1, and then divide by the 0.075, and finally I'll do the multiply here by the 2,000. So 1.075 to the, remember the to the button, 40th equals, that gives me 18 something, and so I'll subtract 1, and I get 17 point something. So if I want to write it out, I might do it again right here. And I have 17.044 dot 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 over 0.075. And so I can just do divide by 0.075 equals, and I get 227 times that 2,000, and those are all my future value calculations. So multiply that by 2,000, and here's the amazing part about annuities. His future value right now at age 65 will be 454513.04 because of that 9. I'll bump up the 3 to a 4. And then I count over 1, 2, 3, put in my comma, put in my dollar sign, and I can see he will have $454,000 when he's ready to retire. So I'm curious if he had just put $2,000 into a sock every year in the corner of his closet, he would have taken $2,000 times 40 years. He would have done that 40 times, and he would only have $80,000. So I like to calculate that, and I usually talk about putting it in a sock or putting it into a can or a pillow or under a mattress because there's no interest being earned on it. But that's the amount of money Marcus is contributing. And if you look at the amount that he's getting from the bank at the end of that time, he's earning a huge amount of interest on this $80,000 that he's putting into this account.